Hey everyone, and welcome to today's Explainer. Today, we're diving into something absolutely foundational. We're talking about the actual terminology researchers use to definitively prove cause and effect in the real world. It's a bit like a giant puzzle, so let's break it down together.
So how do researchers actually prove that one thing causes another? It sounds pretty straightforward, right? But think about it for a second. How do you take a totally abstract idea, like loneliness causes depression, and rigorously, scientifically test it? I mean, you can't exactly put loneliness under a microscope. You have to translate those broad, floaty ideas into a structured reality. And to do that, researchers rely on a very specific toolkit of variables.
Okay, let's dive into this. Here's our structured roadmap for today. First, we're going from constructs to concrete variables. Second, why variables must actually vary. Third, independent and dependent variables. Fourth, the threat of lurking variables. Fifth, controlling the research environment. And finally, background variables and generalizability. We're going to explore all of this through a very specific feline-based case study. Let's get started.
From constructs to concrete variables.
Every single good study out there has to start by defining exactly what it is we're looking at. It all begins with a hypothesis, which is basically an explanation of a relationship between what we call constructs. A construct is simply a property in general abstract terms. For our case study today, let's say we're looking at elderly people in a nursing home, and we hypothesize that loneliness and depression are associated. Loneliness and depression are our constructs here, but because they're just abstract ideas, they could be expressed in 1,000 different ways.
And that is exactly why researchers have to operationalize those abstract constructs into something real. They turn them into variables. A variable is a specific, concrete expression of that construct that you can actually measure or manipulate. You bring the idea out of the clouds and into the real world, or in our case, into the nursing home. Think about the contrast here. You take an abstract construct like loneliness. To operationalize that into a concrete variable, we could just measure it using a self-report questionnaire, like the 20-item UCLA loneliness scale. Or, and this is where it gets really interesting, if we hypothesize that loneliness causes depression, we're honestly better off manipulating the loneliness rather than just measuring it. So we create two levels of loneliness. One group gets a cat to take care of, and a control group gets a stuffed toy instead. The variable of loneliness is now operationalized as the presence or absence of a feline companion.
Moving on to Section 2, why variables must actually vary.
Now that we've got our variables, here's the golden rule. They actually have to change to be useful. If they don't vary, well, you're dealing with a constant. Suppose the nursing home in our study is just so horrible that every single resident maxes out their depression score. If both the lonely and the less lonely people are equally depressed, depression is no longer a variable, it's a constant. The property doesn't vary, which completely ruins our ability to test our hypothesis in this group. For a study to work, the variable central to your hypothesis literally has to show variation. Section 3. Independent and dependent variables. When we're hunting for a clear cause and an effect, we categorize our variables based on the specific roles they play. Our experiment divides really cleanly into two parts. On one side, we have the independent variable. This is the cause, the input, the predictor. It's what the researcher wants to be in control of. In our study, the independent variable is loneliness, operationalized by whether they have a cat or not. On the flip side, we have the dependent variable. This is the effect, the outcome, the response. Its value literally depends on the other variable. We might operationalize this depression by looking at scores on the 15-question Geriatric Depression Scale, or GDS. The researcher controls the cat, the researcher measures the resulting GDS score.
Which brings us to Section 4, the threat of lurking variables.
Here's the thing. Even if your study looks completely successful on paper, it might be hiding a fatal flaw. Imagine the results come back, and the group with the cats has significantly lower depression scores. Success, right? The cats cured the loneliness, which cured the depression. But wait, time for a plot twist. Think about what taking care of a real cat actually requires. You have to get up to feed it, you have to clean the litter box, you have to play with it. What if the experimental group got way more physical exercise than the control group with the stuffed toys? Was it the feline companionship that lowered the depression, or was it the physical activity? That physical exercise is what we call a confounder, or a lurking variable. It's an unmeasured variable of disinterest that's related to both the independent variable, because the cat causes the activity, and the dependent variable, because activity might lower depression.
This confounder can entirely account for the drop in depression scores. If that happens, the relationship between loneliness and depression is what we call spurious. It's basically an illusion created by the confounder. And the really scary thing about confounders is that because they aren't included in the original hypothesis, they usually aren't measured, making it completely impossible to know their true effect.
Section 5. Controlling the research environment.
Okay, so if we want to know for sure if the cat is doing the work, we have to deal with these lurking threats. Here is the absolute crucial point. You can turn a confounder into a control variable. Just like a confounder, a control variable is a property likely related to both your cause and your effect. But the major difference? A control variable is actually measured. By anticipating that physical exercise might be a factor, the researchers can measure the activity levels of the seniors and actually take it into account.
If we structure our data, we can literally hold activity constant by looking at each level separately. First, we compare the active people in the cat group to the active people in the control group. Then, we compare the inactive people in the cat group to the inactive people in the control group. If the relationship between loneliness and depression still shows up in both of those separate comparisons, then boom! We've eliminated physical activity as an alternative explanation. We've successfully isolated the true effect of the feline companion.
Finally, Section 6, Background Variables and Generalizability.
So, we've proven the cat works for our specific group, but who else does this actually apply to? To figure that out, researchers collect background variables, things like age, gender, ethnic or cultural background, socioeconomic status, or education level. Now, we aren't measuring these because we expect them to be the direct cause or effect in our specific cat experiment. Instead, they are absolutely essential for assessing the generalizability of the study. They tell us if the sample characteristics of our nursing home are representative of a larger group, maybe all elderly people everywhere, or even people of all ages. It gives the whole study context in the wider world.
And that brings us to the end of our deep dive into the functions and classifications of research variables. So I want to leave you with a thought to really test out your new framework. The next time you're reading a flashy headline claiming a new miracle cure or some shocking cause and effect, ask yourself, what lurking variable did they forget to control for? Are they measuring a real relationship or just an unmeasured confounder? Thank you so much for hanging out with me on this explainer. Keep questioning the research, and I'll see you next time.